Tell me when you're ready. Okay, well, good afternoon again, or good morning to you. It's good afternoon, yeah. And thanks for joining the chat. As per what I put out, we're going to chat today about water and some of the ions that impact on quality and how you can deal with them. But first of all, I'd just like to ask a straight question. Why is water so important to the brewer? And I'm not looking for technical answers, just why is water's quality and water so important to the brewer?
I mean, it's, one of the main ingredients. It will dictate a lot of the flavor profile of your brew.
Yeah, no, you're quite right on that. But what percentage of a bottle or can of beer or keg of beer is water? What percentage does it make up?
The vast majority. pH is what I would throw out there as
yeah, but I'm talking percentage quality. Water in a say, let's call it a bottle of beer.
99.
Well, you're getting, but that's got 1% alcohol, 99% water. So so if you've got 4% alcohol, 96% water. So it's the majority by a huge amount of what's in that bottle of beer. So it's really the starting point. Of the product. Okay, so that is why it is really a big topic, water quality. But the way I've structured the chat today is let's just look at some flavors that come from water, and how you can, if you do have that issue, how you can deal with it. And I think that I haven't got the list. The order I put up, but I think I've got it right here. The first one, you got a metallic flavor in your product. What gives your product a metallic flavor?
Could it be oxidation, right?
Sorry, I didn't hear that one, Maria.
I'm sorry, could it be oxidation?
Metallic. I'm talking metallic.
Yeah, iron in the water. Iron.
Absolutely. Yeah. If you've got high iron content, I don't know if you've ever sucked a nail. That is metallic. If you do a metallic dope in beer, it tastes just like if you suck a nail. So you want to know what it tastes like, get a nice, clean, shiny nail.
Okay. I was going to ask if you need a clean nail or a rusty one.
Yeah, no, I wouldn't go for rusty ones. Get a clean one. Anyway, so
using a non-stainless pipe in a dispense system or something.
Yeah, so that metallic flavor goes through into your product. Anyone, I don't know if you've been through the lecture yet, but what's the sort of spec for iron content of brewing water? If no one's got an answer, I'll tell you. But has anyone got any ideas what the maximum iron theoretically should be in your brewing water?
Don't know yet.
Okay, 0.1 parts per million, which in my chemistry is less than 100 micrograms per liter. So 0.1 ppm should be your maximum allowed in brewing water. Okay. Now, apart from getting metallic flavor, what else? What other impact does high iron content have on the product?
Yeast don't like it.
Yeah, it's certain that, yeah, and you're going to ask me the level, but certainly yeast doesn't like it. Absolutely. That's a good one. Yeah, I didn't have that on my, but you're quite right. But it also promotes something when it's in the final product, if you've got iron in your final product that you don't want. It helps promote the staling as well. So apart from metallic taste, if you've got iron content, your product stales quicker than if you didn't have the low iron content there. But if you really want it, it does have one positive thing. If you want to look on the positive and have metal and no flavor stability, anyone going to add it enhances something?
Antioxidant?
No, definitely not. That's why it promotes staling. It promotes staling, Michael. Okay, don't get confused. So if you've got iron, it promotes the staling reaction.
We thought it would absorb oxygen.
No.
Which would take it out. Okay.
Well, it in fact helps promote foam stability, believe it or not. But
oh, wow.
Yeah, but that's a buy and buy one, but really you do not want it in your product. But if you've got to look at some of the one positive, it aids,
that's crazy.
It aids foam stability. Okay, but really you do not want iron in your product. There's all sorts of negative things, as we've discussed, apart from the effect on the yeast and the accelerated staling, and especially the metal flavor.
And Brian, let me see if how can I put this question? You can avoid with the water filtration, or is there something, another part of the process that you can try and, do to take that iron out if your water has too much iron?
Yep, I'm coming to that right now. Good question.
Okay.
No, very good question. I'm glad you brought it up, and that I didn't. Very good question. Okay, the one way that you can get your iron out, you need, first of all, sand filters. Okay, and then what happens before the water, and this is my experience, because our water where we brewed here from one of our sources had a relatively high iron content. So you have a sand filter or two sand filters. You need at least two. And okay, and then as the water comes in, it goes through a venturi, and you vigorously aerate the water at about 4.5 bar through that venturi. So you've got your water coming into the venturi, and you pumping air in at about 4.5 bar, which converts the Fe2 to Fe3. So, and the Fe3 then becomes insoluble. So when it goes into the sand filter, it gets caught up in the sand filter, and then takes the iron out. So you've got to make the Fe2 into Fe3 by the vigorous aeration, goes into the sand filter, and the sand filter catches
it. It's all at room temperature?
Room temperature, yeah. Normal temperature, yeah.
Okay,
you don't,
cool.
We didn't adjust temperature. The big thing is, Michael, is the vigorous aeration through that venturi. That's critical to get from Fe2 to Fe3. And of course, your sand filter, you obviously have to know exactly when to switch to the reserve sand filter, and then you've obviously got to backwash the one that's saturated with iron to get all the iron that's being caught out. And backwashing is critical. You backwash from the bottom to the top.
Yeah, the sand bed. Yeah. Are there other types of filtration used? I mean, I guess aeration, you could have all sorts of designs. Are there other kind of designs besides the sand filter?
It's a good question, and I'm not able to answer that one at the moment, but certainly the sand filtration is the common one that's used.
Okay. Sounds affordable.
Yeah. So any further questions about the vigorous aeration, Fe2 to Fe3 gets caught up in the sand filter? And obviously the backwashing of the sand filter is critical. So, you know, you need to measure the water coming out of that sand filter for iron content on a, we used to do it every 8 hours. You know, and generally you basically had no iron actually coming through. It was zero.
And back flushing, do you just use water, or would you use?
Yeah, straight water, back flush with straight water.
They don't use acid or anything.
Sewer. Yeah.
Sorry.
And it went to sewer. You don't recollect that water because obviously it's got a very high iron content.
Right. Actually, could I throw in a question related to that?
Absolutely. That's what we have.
The reverse osmosis purification that kind of mentioned you end up with this really concentrated ion solution. How do you dispose of that? Is that got to be a disposal problem in some municipalities?
I don't know what I don't know what your municipal bylaws allow in the States.
Vary, of course. Yeah.
But from the lectures, what I've understood, it varies. So you have to liaise with your local municipality. Is it? We call the municipality, or your area where the actual wastewater goes. But certainly our wastewater we put to sewer, so it went into the wastewater stream.
That's the same as in malting.
Same as okay. Thanks. Yeah. Thanks for helping out there, Mary Jane. Yeah. Mm-hmm. Does that answer your question, Michael?
I think so. I guess I'm not a professional at this. I just figure there's, you know, chemical treatments that could somehow precipitate really strong solutions. You know, more of an industrial kind of question. You know, if you're dealing with it at scale, is there a handy way to deal with it?
Well, certainly.
But as you say, it would mostly involve the laws, applicable laws where you are. So really,
certainly when we put them in, it was the most economic because all you need is the correct grade sand and 2 sand filters. Because RO is, well, we tested RO. I'll come to, if we get time in this chat, to talking about cation and anion, but certainly we also put a trial reverse osmosis kit in, and we had a relative, we didn't really have that much success, but that wasn't to take out iron, that was to take out chlorides and those sort of things. Any more questions around iron, and can we move on? Everyone happy? Maria?
I'm good.
Yes, please.
Okay. The next one out on the list is one of the old brewers' favorites, and that's sodium. So why doesn't the brewer want high levels of sodium in their product?
Flavor mostly, right?
Absolutely. What sort of flavor, Michael?
Salty.
Absolutely. Yeah.
Dose is one recipe that's salty, but otherwise probably not so good.
Well, I suppose, if someone wants to make a really different beer, you could sort of have a salty background, but certainly you don't want that salty taste in your product. So what's the sort of spec for sodium levels in brewing water? Anyone want to hazard a guess?
I want to say what in between, like the lesson would say that more than 200 parts per million would enhance the salty flavor. So less than that.
Does the lecture say 200 ppm or 200 ppb?
ppm. If you have more than 200, you impart the salty flavor, and if you have less than 100, you have a slightly sweet flavor.
Okay, but looking at specs for water, you'd be looking at less than 10. I mustn't get milligrams per liter, which is 10 ppm.
Okay.
Yeah, the slide
And
says
the reason
100 to 200 or more than 200 being salty parts per million.
Yep. But there are reasons for that, because you know, if you're getting up to that level, okay, and we're talking in water now. Okay, I'm specifically looking at water. So if you have higher levels and then what's coming in on your incoming water, what could be causing that? In the brewing process. Okay, let's think. What is the main cleaning solution used in the brewing process?
Caustic.
Absolutely. So if you're getting high sodium contents in your product, what could be the cause of that?
You're not rinsing well enough.
Yep, absolutely. So that's one of the things that you could be causing it. You're not rinsing. And there's one other thing, another reason that you could possibly be getting caustic in product. Leaking valves. Have you ever experienced a leaking valve? Depending on the type of valve, if it's, you know, sometimes if it's, you've got your various type of valve. You've got your hand operated, which is used in the microbreweries, which is generally a butterfly valve, if I'm correct. But in, you know, the mega breweries, you're looking at automated valves. So if you have a valve leaking, you're going to get certainly caustic contamination, and that's going to certainly increase your sodium content in your product.
Okay.
So that's two things that could happen. If you have very high sodium content in your incoming water, how would you get rid of it? We did speak about it a bit when we talked metallic. How would you get rid of your high iron in incoming water? Let's think about various ways of water treatment. Okay, I'll help you. Ion exchange. But hopefully at the end of the chat, then I'm going to talk briefly about ion exchange, cation and anions and those sort of things. But if by ion exchange, you can take out high levels of sodium.
Okay.
Water treatment. That's if you've got high incoming sodium levels.
And those are with resins?
Yeah, they are. No, it's ion exchange resins. Yeah, but I'll touch on that.
I've never seen that. What's that like?
No, it's a whole chat session almost on its own. You know, the management of your ion exchange resins. But I'll chat. Hopefully we get through this and I can talk for a few minutes at the end of the chat about the ion exchange resins. But
yeah, I just say add distilled water. Would be my fix.
Sorry, Michael.
I just say add distilled water. That would be about as far as I go.
Okay. Yeah, I'm sure that your distilled water is pretty pure. I don't know. Are you buying it off the shelf, or do you make it yourself?
I would buy it off the shelf.
Okay.
I used it in one location or one city that had really minerally water, but only at one time.
Yeah, yeah. Okay. Any more questions around saltiness? Okay, let's move on to the next one. And yeah, if the next one was you related to water now. Okay, related to water. How could water be impacting your conversion in your mash mixer? There's something in one iron in water is very important when it comes to enzymes, especially in the mash mixer.
pH.
Yes. Okay. Certainly, yeah, pH. Okay, but this. Sorry, carry on, Maria.
No, is it the presence of calcium?
Absolutely, absolutely. Very, very important in your mash mixer for two reasons. It impacts pH, which in turn obviously impacts on your alpha amylase and your beta amylase. But what else? Okay, so it impacts certainly pH, but it also does help something else, one of the enzymes in the mash mixer. Okay, what does calcium help? Calcium helps protect an enzyme, one of the enzymes, the critical enzymes in the mash mixer.
Is it related to the thermal degradation of the enzymes?
Yeah, but it protects, it gives one of them protection, assists in the protection of this particular one. Okay, it assists in the protection, and Mary Jane can help me out, of the alpha amylase. So there's two really important things: pH and protection of the alpha amylase enzymes. So it's extremely important, and in the mash mixer. That's not the only reason why you might be having conversion problems. So, and in another chat session, I think it's next week, we'll go into all the others. But we're looking at water here. So that would be what related to water. Calcium is extremely important in the mash mixer. Anyone want to hazard? Oh, something's happened. Yeah. Okay, that's gone. It's fine. Hello, are you all there?
Yes.
Okay, I don't know what happened to my picture, but something happened. But anyway, as long as you're all there, that's the main thing. Spec for calcium in brewing liquor.
At 40 to 60 ppm.
It's a little bit higher. You're almost there, Michael. 50 to 80 ppm. Okay. And just if you're not getting that much in your brewing liquor and you're operating in a brewery, there's a couple of things to watch. is because, and this is from experience, is new operators, because if you're adding salts manually, you know, the operator needs to be trained correctly, how much salt to weigh out for your, especially if you haven't got the right amount of calcium in your liquor, you need to add it by way of generally calcium sulfate.
Mm-hmm.
And that's happened on a few occasions in my experience. New operator, and you know, the training is critical there to make sure you get the right amount of calcium in your mash mixer.
Brian, on that topic, the lesson talks about how you lose half of it during mashing. Can you explain to me why? I mean, from experience, I'm aware of that, but is it like because it's too soluble or thermal? Like, can you explain exactly why this happens?
Yeah, it precipitates out as calcium phosphate.
Okay.
Generally, that's where it's lost.
Okay.
Happy with it? Yeah, it precipitates out as calcium phosphate. So that's where you're losing. So you're always having, generally, you're having a slight excess. And sorry, Michael, I think you were right. It's about 40 to 60 you want, but you're always going slightly above that in what you add, because you're losing some because of the calcium phosphate. Happy? Any more questions?
No, thank you.
Sure. Okay. Okay. Let's move on. The next one was the zinc. Zinc. Do we want zinc in our water, or a brewing liquor, or do we not want zinc in our brewing liquor?
I think you want for the yeast nutrition, right?
Absolutely. And I know this is sort of delving into module 2, which is around fermentation, but certainly you need a certain amount of zinc in your brewing liquor, because it acts in one of the glycolytic pathways as a cofactor. And they normally, people are saying up to 3 milligrams per liter in your brewing liquor. If you haven't got that, which we did not have in our brewing liquor, then you can buy a yeast nutrition. We used to call it a yeast food, which is a zinc supplement, you know, which you can add during wort cooling. So if you haven't got in your brewing liquor, you can add it as a supplement at wort cooling. But there again, you do not want too much, because if you put too much, then it becomes toxic to your yeast. So if you've got fermentation issues, there's lots of things that can cause fermentation issues. But looking at brewing liquor, the first thing to look at is, have you got the right amount of zinc for yeast nutrition? Any questions?
No, sir.
Okay, I'm going to look at another of the elements next, and that is copper. Copper. Do we want copper in our brewing liquor or not?
I would say no, but
yeah, no, you're quite right, and this, you're quite right, and the spec is less than 0.2 milligrams per liter. And why don't we want copper in our brewing?
It's corrosive?
Could be, I haven't seen copper be corrosive, but it does impact in fermentation. Once again, it's all around yeast. It's higher levels, it becomes quite toxic to your yeast. So it's absolutely vital that your copper levels are well controlled. Okay, so we sort of touched on two of the elements. I mean, there's lots more, but I just picked on those two because you really have to watch the levels of your zinc and your copper. Obviously, we discussed iron already in your brewing liquor. Any more questions around those before we move on? Okay, the next one, if you've got high H2S levels in your final product, how can water be causing you that problem?
High H2S, hydrogen sulfide.
Yeah. If you've got high hydrogen sulfide, what is the, for want of a better, one of the precursor of hydrogen sulfide?
Sulfur dioxide. Is this the one where you're near a treatment plant where you're picking up from an industrial process?
Sorry, just repeat that, please, Mike.
The lecturer mentioned you could pick up some impurities through being near an industrial process.
Okay, I'm referring here to brewing liquor. So if you're finding you've got high levels of H2S, what iron in your brewing liquor could be the precursor of this problem?
That I don't know.
Okay, no, it's fine. It is sulfate. So sulfate in fermentation is one of the precursors of H2S being formed. But, sulfate is, and when you go through the lectures on water, it'll come out that sulfate is also an important ion in beer flavor as well. So you need a certain amount, but you don't want obviously too much. So the spec, according to the literature, is about 40 to 100 milligrams per liter of sulfate. And have you heard of Burton beers?
Burton-on-Trent.
Burton-on-Trent.
High sulfate.
Very famous brewing town in England.
Yes,
if you go there, if you have the fortune to go there and drink their beers, a lot of their beers are really, they're called Burton beers. Very high levels of sulfate, up to, I think, about 500 ppm, and they are very sulfury beers. But it's traditional Burton beers. Okay, so you do want a certain amount of sulfate in your product, but if you don't want high levels of sulfur, you don't want extremely high levels. So, as I say, in the brewing liquor, they're looking at about 40 to 100 milligrams per liter.
Okay. You started the question with H2S levels. Does high calcium sulfate produce high hydrogen sulfide? They're kind of a...
Yeah, obviously the sulfate, if you put in huge amounts of excess calcium sulfate,
okay,
it's would be similar to having brewing liquor with very high levels of sulfate, which would go through into your fermenter.
Okay.
So you can either take your sulfate out, so your brewing liquor has the right amount of sulfate.
Right.
Does that answer your question?
Yeah, certainly that'll be ideal. I guess I'm not sure what it takes to molecularly break the sulfur out of the sulfate group. I assume that's a fairly stable molecule. It would be some metabolic pathway where it, the sulfates were attacked by something else, and that H2S was a byproduct. I'm not sure under what circumstances that would happen. If there's just too much sulfate and that happens to it, or if it's kind of an anomaly, created by something else. That I'm not sure about how to get the sulfur out of the sulfates.
Yeah, but during the process, they would certainly split, because okay, I know we're talking, we're delving into fermentation again, but you need a certain amount of calcium in your fermenter as calcium Ca plus for yeast flocculation.
Right.
Okay. So the split does happen, and you're getting calcium and sulfate. Is everyone happy with that?
Yeah, sure.
Okay, so we dealt with sulfate. Once again, and the way, if you've got high sulfate levels, ion exchange is the method to take it out. And we'll hopefully we'll have a minute to chat about ion exchange just now. Okay, the next one, you're having stress corrosion in your brewery. I don't know if any of you have experienced stress corrosion, because there's one particular ion that, when heated, causes stress corrosion even in the most high-grade stainless steel. Anyone want to hazard a guess?
I have no idea, honestly.
Okay, and it's, in fact, it's
Calcium
chloride. Chloride.
All right.
But
Okay.
it's in the water's got to be heated above 80 centigrade. So if you've got chloride levels, not chlorine, because some students get mixed up between chlorine and chloride. You've got high chloride levels in your water, and the temperature goes above 80, it becomes extremely corrosive, even to the most high-grade stainless steel. Just a bit of history. The last brewery here in the town where I lived, before we commissioned the new brewery, was really old. I think I've explained that in one of the previous chats. And it was not possible to take out the high chloride levels. And the W85, or the sparge water main, we would have to replace that every 2 years because of pitting caused by the high chloride level. So, yeah, and so you need, and the spec is less than 50 ppm in your sparge liquor, or if you're rinsing out your caustic with 85 centigrade water. The spec for those two streams is less than 50 ppm of chloride.
Okay.
So, and yeah, ion exchange again is the way to take out if you've got high levels of chloride. Questions?
Nope.
Same for malting water.
Okay, thanks, Mary Jane. Same for malting.
Yeah.
Okay.
You
So
go through your stainless steel way too fast.
okay, so are they even in your maltings reducing the chloride levels down to less than 50 ppm?
I believe it is less than that.
Okay. No, thanks.
It's been a bit since I looked at water analysis.
Okay. Yeah, me too. But certainly I experienced chlorides. That's a definite. Okay. The last one, I think, on the list, if you've got a phenolic or flavor in your product. Phenol. Anyone want to guess how a phenolic flavor comes from your water? And how to get rid of it?
There's an effective alkalinity, according to my notes here.
No. No. There's two things that you need for the chlorophenol molecule to form. And that is chlorine and high organic level, plus heat. And then you get does everyone aware of what chlorophenol is? It's like a Dettol. I don't know if you get Dettol in the States.
Or Band-Aid flavor.
Band-Aid.
Aroma.
Yeah, you could call it Band-Aid. Yeah, it's like a antiseptic.
Medicinal.
Medicinal. Thank you.
Yeah,
That's the word I
medicinal.
was looking for when I was talking that. Medicinal. Thank you very much. I'm getting tired. Okay, well done. No, medicinal. Yeah, medicinal. So if you've got chlorine and you've got high organics, you're going to get the medicinal flavor with heat. And so you've got to remove the chlorine. And how would you remove chlorine? Okay, carbon filtration. Everyone heard of carbon filtration?
Yes.
Yes, activated charcoal.
Activated charcoal, yeah. So yeah, so you need activated charcoal filters, and that will take the chlorine out. So you need to put your water through active carbon filters, and you need to keep a close watch on the carbon filters that need to be regenerated with steam. So as soon as you get breakthrough and you got chlorine coming through, then you need at least 2 carbon filters, backwash, and steam to make the sites on the actual activated carbon open again to catch the chlorine. Just something, if you are ever going to put active carbon filters in. When we did the new brewery, we made sure they could, I forget exactly what back pressure they could take, but so we could actually, with a slight back pressure, get the temperature in the carbon filter up to 140 centigrade, because that really cleaned the chlorine off the carbon molecules and extended the life of the carbon.
Yeah, I guess with the cleaning chlorine out, it works at a lower temperature. I've gotten the idea I had to get activated charcoal up to 1,000 degrees to reactivate it.
Yeah, that's okay. Yeah, we're talking. Okay, I hear what you're saying. You can. Okay, if you've got activated carbon in your stainless steel vessels, after ours used to last up to approximately 18 months, then you would have to take all that carbon out, because even with the steaming, the actual carbon molecule itself needed regenerating. So you would have to take that out, send it off to a facility that actually regenerated that active carbon. Does that answer your question, Michael?
I think so. Sounds like this is a lesser,
just
more
building on that. We tried that once, and the life of the regen carbon coming back was like, it was no more than 3 months as opposed to 18 months for the new carbon. So in our experience, you know, the actual taking away and regenerating at these extremely high temperatures it wasn't that successful. It could be done, but it wasn't that successful.
Okay, thank you, sir.
Any more questions on that? And then what's the time? Yeah, we got to. Then I just want to talk a little bit about cations and anions. Any more questions? You know, it is a rather complex subject we spoke about today, but hopefully, you know, once perhaps listen to the chat again, I hope that I've got all the points across as simply as possible. Any more questions before we just have a brief chat on cation and anion? Okay, let's have a look, a brief look at cation and anion. Cation resin. Okay, so when your water, it depends what you want to take out, but your cation resin takes out your calcium, your magnesium, or those sort of metals, sodium, and it releases a hydrogen ion. Okay, so the water comes in, that resin will catch the calcium if you want to take the calcium out and release a hydrogen ion. Everyone happy with that? So if you've got calcium, say, sulfate coming through, you're going to end up with the hydrogen combining with the sulfate going through to the next resin, which is the anion resin. So you get an acid going through to the anion, which will then catch the sulfate or the chloride and release an OH ion, and you end up with mineral water coming out of your cation. So that's how you're removing the calcium, the magnesium, or sodium, and the chlorides and the sulfates. And you end up with mineral water. HOH. Everyone? Questions, please?
I'm completely unfamiliar with how they work. It's quite elegant, but can they be recharged?
Yeah.
Are they rechargeable?
Yes, no, I'm coming to the regen. That's absolutely critical, the regenning of these. So basically, your cation will grab a calcium and release a hydrogen, okay? And then your anion will then grab a sulfate and release a OH. So if they're working properly, you end up with an HOH, which is mineral water. And the regenning of these is absolutely critical. And so your cation is regened with a 30% HCl solution, which adds the H back onto the resin and will take the Cl off, or and and that water actually gets rinsed down the drain. So you're actually putting the hydrogen back onto the resin, and your anion is regened with caustic. So NaOH, the OH then gets put back onto the resin. And I just want to keep it as simple as that, because I don't want to complicate it anymore. But the regenning is absolutely critical. And you actually have conductivity meters after the cation and one after the anion. And so when you get a certain conductivity spike, that automatically puts the actual anion or cation into the regen mode. Any questions on the basic operation of the cation and anion and the regenning of them?
Seems fairly straightforward. Are the sounds like hydrochloric acid and caustic, are they particularly strong? Are they very dangerous?
Yeah, okay, sorry. Yeah, the hydrochloric acid was a 30% solution, and the caustic a 25% caustic solution.
Reasonably strong.
Yeah, reasonably strong. Yeah.
Okay. Is the resin technology very expensive? Is it something a small or craft brewery could afford, or big boys?
It is, Michael. It is expensive, and you know, I'm trying to think. At the time, I'm talking a while ago now, it certainly was expensive to run that plant, but you know, depending on the incoming quality, we had no choice, because the incoming quality of our water had high iron, it had high chlorides, it had high sodiums, and also high in organics. So, you know, we certainly had no choice but to use the ion exchange method. Sorry, I've got no cost comparisons of the ion exchange as opposed to the reverse osmosis, but as I said, we tried a little test RO kit, and we really struggled to get the same quality water as we were getting out of the ion exchange water treatment plant.
Okay, thanks. Yeah, it seems like these things are getting cheaper all the time, but more advanced technology gets scaled down to smaller breweries.
Yeah, you know, it's the actual regenning costs. You know, they were high, and obviously, the more what you don't want in your water, the more often you'd have to regenerate. You know, and so that would push the cost up, because we had two water streams. The one water stream, we could actually run the ion exchanges for about 3 days without regen. The other water stream, we were regenning every 12 hours. So it's all relative, but it's not a cheap process. You know, that's definite. But as I say, if you got a fairly small to medium sized brewery, I'm not talking, you know, craft brewery, you know, then these water treatment plants are absolutely necessary, especially where your water quality is not up to standard for brewing liquor.
Right. Seems like maybe scouting locations first, finding cities with good water would be a
No, I
step one.
totally agree.
Avoiding places with mercury and things like that.
Yeah, no, I totally agree. If you know, if you can build a greenfields brewery, but then you don't want to also transport your beer halfway across America either. So you've also got to balance that out.
Yeah. I lived in California for a while, the gold mining territory, and the concern was mercury in the water.
Really?
Is that still an issue in parts of California? Do all the breweries have to treat their their incoming water for heavy metals?
I don't know if Mary Jane can help us on that, but sorry, I don't know the answer to that one.
As far as mercury, I'm not sure on mercury, but if you look at a large brewing conglomerate that has different breweries in different towns, they'll actually have different water systems for each brewery, depending on what they're starting with is their kind of house water.
Yeah, right.
And they'll fit their water treatment in order to do that. So some places, you've got more salt in it, and more heavy metal type, or not heavy metal, but metal ions, things like that. So I would assume that the mercury would still be there if it was there at one time. So that would have to be managed.
So I'm told. Okay, thank you.
Okay, but anyway, everyone, thanks very much. Thanks again for joining. It's really appreciated. I know it is a tricky subject, and hopefully, we've covered some of the aspects.
I won't be joining you next week. I'll actually be giving a presentation at the Craft Maltsters Conference on malt for distilling. And so I hope you have a good week. But since I won't see you the next time.
Okay, we'll see you the time after. Now, thanks very much.
Thank you.
Yeah, indeed. Thank you.
No, thank you. Thanks very much, everyone. Thank you for your input. It's really appreciated. Thanks very much. We'll chat next week.
All right.
Bye-bye.
Thank you.
Okay, bye now.